find it interesting that the book, or at least the quiz, does the multiplication after the division, because there seems to me that they should go in the other order. But again, we're just multiplying 18i plus 21i squared. That I squared is going to go to a -1. So we get a -21 plus 18i, and in standard form, that's going to look like that. 4i, not squared, 4i plus 4i squared. So that I squared is going to go to -1. That'll give me a -4, -4 plus 4i. Last two, I prefer to do the number d because it's a difference in two squares. I'm just going to get 49 minus I squared, or 49 minus 1. Our complex numbers totally go away on this one. Okay, that's kind of the idea of the conjugate above. 24 minus 8i plus 6i minus 2i squared. 24 minus 2i minus 2 times -1. That'll give me a positive 2, so I get a 28 minus 2i. Okay, this is the same idea. We're just going to add and subtract. They just are giving us a extra set of parentheses to tell us what order to do it in. So for, I have a mistake here. That should be a 1, not an I. Yeah. 4 plus 1 plus 2i minus 6i. We get 5 minus 4i minus 5 plus 3i. So 5 minus 5, that goes to 0. -4 plus 3, this gives me a -i. Okay, solve the equation using factoring or the quadratic formula, whichever is appropriate. Well, I'll tell you what. On the XYZ quiz, none of these are factorable. And last thing I'm going to talk about is down at the bottom. But I'm going to run you through the quadratic formula. The first thing I'm going to do on A is I'm going to clear the fractions by multiplying everything by 8, the common denominator of 2 and 4. So I get 4x squared plus 8 equals, 4 goes into 8 twice, 2 times 5 is 10x. Let's get everything on one side. 4x squared minus 10x plus 8 equals 0. A, B, and C. And x is, this is the quadratic formula. Negative OI, couldn't decide whether or not to go to a square party, a radical party. The boy was squared, so he missed out on 4 awesome chicks, and the party was over at 2 a.m. And I'm going to take up the space for this one because I'm not going to do the right-hand side. I'm just going to point out to you that it's the same thing. So negative 10 plus or minus square root of -10 squared minus 4 times 4 times 8 all over 2 times 4. So 10 plus or minus the square root of 100. 16 times 8 is 128 all over 8. And that gives me 10 plus or minus the square root of -28 all over 8. I looked into this, and you are going to have to reduce these. It will not take a non-reduced answer on these. And here's what I mean. I can factor 4 out of the 28, and I'm also going to factor the negative and come up with I. So 10 plus or minus I, square root of 4, square root of 7, all over 8. 10 plus or minus 2i, square root of 7, all over 8. Now, 10, 2, and 8 can also all be reduced by 2, and it's expected that you do. So I get 5 plus or minus I square root of 7 over 4. And like I said, they will not accept on these particular problems a non-reduced answer when you're using the quadratic formula. Now, look at B. And if I add 2x to one side, I get 2x squared minus 3x plus 2 equals 0. I have to use the quadratic formula. That thing is not factorable. So just get a 0 on one side on problems like this and use the quadratic formula, just like in part A. Okay, the very last question asks you to judge whether or not a equation is factorable or not. And here it's simple factoring. So if it's factorable, I can find two numbers that are the factors of 15 that add or subtract to give me 8. So if I look at the factors of 15, and I'm definitely adding because that 8x is positive and 15 is also positive, I get 1 and 15. When I add those, I get 16. And I also get 3 and 5. When I add those, I get 8. So this is totally factorable. X plus 3, x plus 5. Looking at a really similar problem, only I'm looking for two numbers that multiply to give 10 and add or subtract to get 8. Well, I get 1 and 10. Those give me 11. I get 2 and 5. Those give me 7. I don't get close to 8, so not factorable. And that's all I have for you. I will see you in class.